Hello everyone, dear students of class 10th. Today we are going to start chapter number 15, probability, and here is only one exercise in this chapter, exercise 15.1, and we will do this exercise. Okay, so first of all we have to understand the probability of happening an event. So we have a formula for this: number of outcomes favorable to event A divided by total number of all possible outcomes. Okay, you know very well about this formula from junior classes. And we have also one important point: sum of all the probabilities of all the elementary events of an experiment is 1. Okay, so this is again very important. In general, it is true that for an event A, probability of not A, E dash E bar represent not A, is equal to 1 minus probability of A. So E bar representing not A, and it is known as complement of event A. Okay, and last important thing is that probability of happening an event is greater than equal to 0 and less than equal to 1. So this is the range of probability of an event. Okay, so now we have some important points also. We know when we toss a coin, then we have two possible outcomes, head and tail. And when we throw a die, we have possible outcomes 1, 2, 3, 4, 5, 6. Okay, and when we draw out a card from a well shuffled deck of 52 playing cards, then we have here cards of 4 types: spades, heart, diamond and clubs. You have given in your book, you can check them here on page number 301: spades, heart, diamond and clubs. Okay, there are 4 aces. Okay, and you can do all the questions on the basis of this knowledge. Students, if there is some event which is certain to happen, then its probability can be 1. Okay, and if there is an event which is impossible to occur, then its probability will be 0. All right, so you know about sure event and certain event. The probability of sure event or certain event will be 1. Okay, now we are going to start exercise 15.1, and first question is here: complete the following sentence. Probability of an event E plus probability of the event not E. This will be 1. Okay, the probability of an event that cannot happen is 0, and such event is called what? Impossible event. Okay, such event is called impossible event. All right, similarly, next we have the probability of an event that is certain to happen is 1. Such an event is called sure event or certain event. Next, fourth point is here: the sum of all the probabilities of all the elementary events of an experiment is 1. Okay, and last is here: the probability of an event is greater than or equal to 0 and less than or equal to 1. Okay, so students, I told you about these basic ideas already, so you can fill up all these parts by yourself. And next one is we have given question number 2: which of the following experiments have equally likely outcomes? Explain. We have given a driver attempts to start a car. The car starts or does not start. Okay, so the outcome is, this outcome is equally likely. So we can say the outcome is not equally likely because the car starts normally when there is some defect, the car does not start. Okay, तो हम कह सकते हैं कि कार स्टार्ट भी हो सकती है, ओके, और नॉर्मली धीरे से भी स्टार्ट हो सकती है, ओके, एंड द कार डज नॉट स्टार्ट, और कार स्टार्ट नहीं भी हो सकती है, ओके, दिस इज नॉट इक्वली लाइकली. Next we have given a player attempt to shoot a basketball. She or he shoots or misses the shot. So this one is again not equally likely outcome, because the outcome depends on the training of the player, because outcomes depend on the training of the player, okay. Third part we have given a trial is made to answer a true false question. The answer is right or wrong. So this is what? This is equally likely outcome, because there is only one answer, either it is true or false. So it is equally likely. A baby is born, it is a boy or a girl. So it is also equally likely outcome, because if a baby will born, it will be either a boy or a girl. So it is equally likely outcomes, right? Now next third question is here. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? So we can answer question third as, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? This is why, because when we toss a coin, the outcomes head and tail are head and tail are what? Equally likely. So the result of an individual coin toss, the result of an individual coin toss is completely we can say unpredictable, ओके, completely unpredictable है, तो इसलिए इसको हम कह सकते हैं कि ये क्या है, एक fair way है of deciding which team should get the ball at the beginning, okay. Next question we have given, which of the following cannot be the probability of an event. तो स्टूडेंट्स आपने देखा होगा कि probability क्या होता है, 0 से 1 के बीच में लाई करता है, 0 भी हो सकता है, 1 भी हो सकता है, तो नेगेटिव नहीं हो सकता है. B is the answer, right? Probability of happening an event cannot be negative. Fifth question is important. Probability of happening an event A is equal to 0.05. What is the probability of not A? Actually question number 5. Probability of A is given 0.05, and we know that probability of A naught is equal to 1 minus probability of A. So we can easily find out 1 minus 0.05, and we have to subtract, okay, and on subtracting we will get 0.95 answer, okay. This is the probability of not A. Similarly, we have here many questions like that. A bag contains lemon flavored candies only. Malini take out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy or lemon flavored candy? Okay, a bag contains lemon flavored candy only, okay. So this question is very simple, right? Because a bag contains, question number 6 we can do this way, because a bag contains only lemon flavored candies, okay. Therefore probability of an orange flavor candy, first part we can say an orange flavored candy will be equal to 0 because it has only lemon flavored candy, so orange flavor candy will be not there. And second one part is what? Probability of a lemon flavored candy will be equal to 1. Okay, so this question was very simple. Now next question number 7 is here. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that 2 students have the same birthday? So you have to find here probability of E. Probability of not E is given. Okay, so you have to do this question by yourself. 8th question is again very simple. 9th question is simple. 10th question is simple, right? Okay, similarly 11th question. Okay, 12th question. Let us do question number 12. Rest questions are very simple and you can do them easily by yourself. What is 12th question? A game of chance. A game of chance consisting of spinning an arrow which comes to rest pointing at one of the number 1, 2, 3, 4, 5, 6, 7, 8, and these are equally likely outcomes. What is the probability that it will point at 8, an odd number, a number greater than 2, in a number less than 9? The question is very simple, but let us do it. Okay, question number is 12. First part, probability getting 8. Probability of getting 8. So here is only 1 8, so and total outcomes are 8, so 1 upon 8. Okay, because there are only 1 8 and total number of possible outcomes are here 8, right? Second part is here, probability of an odd number. Probability of an odd number. So students, you know very well here are how many odd numbers in this game of chance. Okay, you can see here odd numbers are here 1, 3, 5 and 7. So there are 4 odd numbers here and total numbers are here 8. So 4 upon 8 and the answer is 1 by 2. Similarly, third part of this, probability of a number less than 2. Probability of a number less than 2. The less than 2 are here only one number. Less than so it is asked here greater than, not less than, greater than 2. So greater than 2 are here 6 numbers. So it will be 6 upon 8 and that is 3 upon 4. And fourth part is here, probability of a number less than 9. A number less than 9. Less than 9 are here all numbers 1 to 8. So it is 8 upon 8 and the probability is 1. So students, this was question number 12. Similarly, question number 13 is very simple. Is a question of die. Question number 14 and question number 15. Just I am doing here question number 15 because you will get the idea of cards from here also. 13 and 14 you will do by yourself. So question number 15 are here 5 cards. The 10, Jack, Queen and King and an ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is the Queen? If the Queen is drawn and put aside, what is the probability that the second card picked up and as a Queen? Okay, so हमें इस क्वेश्चन को पहले समझना है और फिर समझने के बाद हमें इसको सॉल्व करना है. Okay, so let us do question number 15. Okay, so out of 5 cards there is only one queen. Okay, out of 5 cards there is only how many queen? There is only one queen. Okay, so what is first probability of getting a queen? Probability of getting a queen is equal to 1 upon 5. What is second case here? Probability of NS. Probability of NS, because according to question second, if the queen is drawn and put aside, क्वीन निकल चुकी है और हमने उसको एक साइड रख दिया है, हमारे पास टोटल नंबर ऑफ कार्ड्स बचते हैं 4, तो एस उसमें से आ सकता है, तो 1/4 हो जाएगा. एंड बी प्रोबेबिलिटी ऑफ अ क्वीन, क्वीन की यहाँ पर क्या हो जाएगी, क्वीन वहाँ पर नहीं है, हमने साइड में रख दिया था ऑलरेडी, तो 0/4 दैट इज इक्वल टू 0. So it was question number 15. Similarly students, you can do question number 16, 17, okay, 18 by yourself. Okay, I am doing here question number 17 because question 17 and 16 are similar, and you can easily do question number 18, 19 by yourself. Okay, so I am doing here question number 17. What is question number 17? 17, a lot of 20 bulbs, a lot of 20 bulbs contains 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? 4 defective and 20 bulbs are total. It is very simple, 4/20. Okay, so next is here, suppose a bulb drawn in first is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that bulb is not defective? So it will be again not defective, means suppose a bulb drawn in first is not defective. So what is the probability that bulb is not defective? So there are means we can say 15 bulbs which are not defective left in the lot. Okay, so we can write 15/19. So let us do this question. Total number of bulbs, total number of bulbs is equal to 20. Number of defective bulbs, number of defective bulbs is equal to 4. Therefore probability of bulb drawn is defective. Probability of bulb drawn is defective will be, defective are 4 and total are 20. It is 1/5. This first case, and second part is here. The bulb drawn in first case is not defective and not replaced, then we have to draw out one bulb again. Remaining bulb are here. Remaining bulbs are how many? 19. So therefore probability of getting a bulb drawn is not defective. It will be equal to 15 bulbs are which are not defective, because number of defective bulbs are 4, so number of non-defective bulbs are 16, but one bulb is drawn, and for second case the bulb drawn is not defective, so remaining bulb will be 15. So 15/19. Okay, so the answer. Similarly students, you have to do 18, 19 questions by yourself, and I am doing here now question number 20. Let us see. This question is not from exam point of view, but you can do it. Suppose you drop a die at random on a rectangular region shown in figure 15.6. What is the probability that it will land inside the circle with diameter 1 meter? So students, here you have to find the area of both the rectangle and area of circle. So you can find out it very easily. What is the area of rectangle? First of all, for question number 19, question number 19, just see here, what is area of rectangle? In this case you have given the figure, so we can find area of rectangle because you have given the dimension 3 by 2, so it is 3 into 2, length into breadth, 6 meter square. And what is area of circle? Area of circle, it is diameter is given to 1 meter, so radius will be 1 by 2, so it will be pi 1 by 2 square, that is pi by 4 meter square. So therefore the probability that the die drops inside the circle, the die drops inside the circle will be area of circle upon area of rectangle, that is pi upon 4, okay, upon 6. So it will be pi upon 4 into 6 and pi upon 24 is the answer. Students, you get question number 20. Now question number 21 is important and very simple. Okay, you can do it by yourself. Question number 22 is for yourself also. You can do it by yourself. You have to complete the table. Question number 23, 24 and 25. So I will do here question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcomes each time. Hanif wins if all the tosses gives the same result, 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So it is very simple. Possible outcomes in this case. Question number 23. Possible outcomes are what? Head, 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 tail, 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 head, head, tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, tail, and head, tail, tail. So total number of possible outcomes are 8. Okay, and probability of win the game, is here. How much? He will get either 3 head or 3 tail. He will win. So there are 2 upon 8. It is 1 upon 4. Hence probability of he lose the game. Hence probability of lose the game will be equal to 1 minus 1 upon 4, that is 3 upon 4. Okay. So now question number 24 is again very simple question. You can do it by yourself. And last we have question number 25. Last question of this exercise is question number 25. Which of the following arguments are correct and which are not correct? Give reasons for your answer. If 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, and one of each. Therefore, for each of these outcomes, the probability is 1 by 3. argument is correct or incorrect, we have to tell. And second one is given, if a die is thrown, we have to give the reason. Okay, if a die is thrown, there are two possible outcomes, an odd number or an even number, therefore the probability of getting an odd number is 1/2. So we have to tell whether the argument is correct or incorrect. So in first case, in question number 25, in first case the argument is incorrect. Argument is incorrect. Why? Because the possible outcomes are, because the possible outcomes in the given condition are head head, head tail, tail head, or tail tail. Okay, these four. So probability of getting head head is 1/4, probability of getting tail tail is 1/4, and probability of getting head tail or tail head is 2/4, so 1/2. So not 1/3, we have given here 1/3. Second argument, in case of throwing a die once, argument is correct. Second argument is correct. Why? Because possible outcomes are what? Possible outcomes are 1, 2, 3, 4, 5, 6 in case of a die. Okay, odd numbers are here. Odd numbers are 1, 3 and 5. The probability of getting odd number is equal to 3/6, that is 1/2, and even number is equal to 2, 4, 6. So probability of getting an even number is equal to 3/6, again 1/2. So in both the case it is correct. So students, it was exercise 15.1, and with it chapter 15 probability has been finished. For any doubt anywhere, you can ask me on WhatsApp. So practice more and more. That's all.